Hello, Montana. Gotta adjust my camera so you can see my new haircut. Got a haircut, first one in 5 months. Uh, Hopefully the next one won't be 5 months long either, but we'll see how that goes, depending on the quarantine. Anyways, so we know how to get data out of a database. The first three lectures, lecture 1, 2, and 3, how to get data from the database. You got your tables and you write your queries and then you put some reports at the bottom and it's all beautiful and you get an A from your boss. But sometimes you have to design databases. You've got to create those darn tables. The first assignment, we just gave you the tables. Now we're going to make you do something with the table, make the tables yourself. And if you're going to design tables, you might as well do it the best way possible. There's lots of ways to design tables. You could have one table for every field. That would be a bad idea. So how do you do it? Let's talk about it. I've got some examples and some principles, and I'll try to show it to you next week. The next kind of 3 weeks are going to be about designing databases. So get comfortable. It'll be a bit of a ride. This one's more exemplary. We'll just show you a bunch of examples, a few principles, and then we'll move on to some more details in the next week or two. You don't have to start designing them in your labs until week +1. So that's good. Great. So that's the wrong screen. So the objectives are to get you figuring out how to design and how to design from specifications. People come to you and they say, I need a database that does this. And your job is to parse out that, to think about what they're saying and extract out the objectives. And you'll need to do that for the exam as well and the assignment. And so it's good practice as well as in the real world. Definition bingo. So you're going to learn these words. Always when you're learning a new thing, there's a bunch of new terminologies. It's good because then you don't have to say, oh, the thing that does X and Y and Z. It's the primary key. The primary key is the thing that uniquely identifies a row in the database, a row in a table, in fact. A foreign key is a thing that points to that row from another table. An entity is basically another word for table, and relationships are the relationships between the tables. Cardinality is this idea of 1 to 1, 1 to m, m to m. Those are the words we're going to learn later on in this tutorial, but just to give you an idea, so that in your head you sort of got a place to put them, a little blank spot you can fill in the blank later on. So when you're designing a database, you need to have these things. You need the structure, you need the fields, which fields are going to go in which tables, what are the tables going to be, what are the fields, and what are the relationships between the tables. So in the previous assignment, you saw we had a diagnosis table, we had a DS1 table. Those are the tables. The fields are TDIAG1, TDIAG2, and the relationships were implicit in that table. The relationship between TDIAG1 and code ID in the diagnosis table, TOPR1 and code ID in the procedure table. Those were the implicit relationships. But it's good to think about what are the proper relationships. What should we name them? How should they join up together? And then finally, you want to be able to format your fields. You want to be able to have rules to say this data has to be this kind of thing. And we're going to talk about that in the next lecture. Today is these things. The next week is that stuff. Oh, I turned the wrong key. It would have looked a lot better if I would have used that key. Cool. So what is a table? What does a table look like? Tables are rows and columns of data. So rows, the sex table has got sex and description. Columns, sex and description. Rows, 1 male, 2 female, 4 indeterminate. Sex is such a beautiful little table. Small, useful. Then in the main table, the admission table down here, we don't have to put in male, female, man, woman, boy, girl, all the different ways we use to attribute gender. We can just put a 2. That means female. This row here, person 1469 is female, 32 years old, length of stay 1. We don't have to add in the information. We can keep the data in this table, and we join up to that table. We join to that table. Similarly, admission source. We don't need to put transfer for mental health residential facility. We can just put an A in there. H is the standard one, admission for private residence. Yeah. Similarly, so that's so this is called what is a table, and then we can start to think about the relationships here. We've got what's the relationship between sex and admission? Well, for every admission, there is one sex, there's one gender. This admission is 2, but for every gender, there is multiple admissions. So that's a many to one relationship. There's many admissions for a single admission. There's one sex, so there's a one to many relationship. Similarly, there's an admission source. There's one admission source and many of these things. On the other hand, the relationship goes the other way for admission diagnosis. Admission diagnosis are all the diagnoses for admission 2100 1469, and there's 6 of them right there, and those are the codes for them and their position and so it's instead of T-Diag1, we have them laid out lengthwise. It's a long version of the table, and you can see how that connects up over here because they connect up so it's a many to one relationship, but the other direction. Tables, relationships. Oh, I did it again. Pushed the wrong button. Relationships. So this is an idea of what the relationships look like. So as I was sort of implying earlier that we had these tables called the admission, we had sex, admission diagnosis, admission source. They're here, and this is what they look like in Access, the Access relationship diagram. This is not an. Later on, I'm going to teach you about an ER diagram, an entity relationship diagram. This is not an ER diagram, but it's similar. It's got the relationships between the lines, and so we've got sex here is related to sex there. Isn't it lovely? They're named the same. In your first assignment database, they weren't named the same. You had T-Diag1 over here and code ID there. So it's nice when they're named the same. It's nice when there's a line joining them up so you can see, oh, these two things are joined to each other. Yeah, diag code is related to diag code, not T-Diag1 and code ID. It still does have code ID there, though. Call it a vestigial thing. This is what a larger scale database looks like. So what we're going to do is we're going to teach you the principles about how to build this. Given a description, how do you make a database like this? So there's one rule. There's one rule. It's the rule of ones. I made that up just earlier this morning. Tables hold one kind of thing. So you don't have a table that has procedures and diagnoses in it. You know, why would you? There's lots of space in the database. You have one table that has procedures in it and one table is diagnosis in it. Then you can have all the information about procedures and you can have all the information about diagnoses. So here we've got diagnoses here. We've got procedures there. You see the procedures has got block. There's no block in diagnosis. So why would we have them be the same thing? We want to have them in separate little spots as well. They join up completely different ways. So admission table holds admissions. Admission procedure table holds procedures for that admission. Procedure description table holds the procedures and the descriptions for those procedures. The sex table holds sexes, the different types of sex that exist in the world. So each table holds one type of thing. You don't try to cram multiple things into it. Also, I mean, in a similar thing, each table has one cardinality. So there's one. Each line is one admission in this table. Each line is one sex. You don't try to cram multiple sexes or multiple admissions in the table. That was a problem with the previous assignment. We tried to cram 25 diagnoses into one line of the table. Not a smart thing to do. It had problems. Each table should hold one kind of thing. Fields should hold one kind of thing. So if in the sex field, you just have sex. You don't have other things related with sex. I don't know. Um, Genetic code. You try to just have one kind of thing. So it's this idea of a division of labor, I guess, one kind of thing. Those are the rules. I'll tell you. We'll talk more about it later. And then no duplication or redundancy. Each data item is in only one place. Sometimes it feels good to be able to put a person's name here in this table, and then also put a person's name over here because name's useful. But don't do that. Instead, put the ID of the person in both tables and use the ID to go look up the person's name. Why do you do that? I'm going to talk about that at length, but why do you have no redundancy? Because if there's a saying, a man with one watch knows what time it is. A man with two watches is never sure. If the data is in two places, well, sure enough, my grandma had a saying about that, but uh, uh, sure enough, you're going to end up with different data, and then you're going to be scratching your head, going, "What is the correct data here? Which is the correct data?" So don't do it. Put the data only in one place, and then use the primary key, foreign key. Use the linkages between the tables to go look things up, and that's why each table needs a primary key. A unique attribute for every row, so you can go look it up. You can go say, well, what is the admission details? What is the sex? What is the canonical version of what do we call the sex number one? Male. Why do we do that? We use the primary key to go look it up. I'll go back to that table. If I say, how do I find out what sex number 2 is? Oh, that's the primary key. That's a foreign key here. So we can use it as a primary key here. We can go look it up in the primary key here, whereas it's unique. So where there's not two number 2s, there's only one number 2. And we say, oh, that's female. So we don't have to worry about it. We don't have to put female in there. We don't have to, worry about all that stuff. It's in another table. Those are the rules, and that makes sense. So, and each field name should be unique. So, for example, diag code and diag description, you can't see it down here, should be unique. You shouldn't call it don't call it code ID, for example, in both tables, because that's not unique. You don't know which one it is. Don't call something name. Call it person name or procedure name or separation mode name. So here we've got, actually, there is a problem down here in this database. These 3 fields here both have a CD underscore desk, and they probably should say admission source desk, admission type desk, care type desk, and separation mode desk. Meh. Not every table is well designed. So yeah, each field name should be unique and define the thing that it's supposed to define. So not all databases are well defined, are well designed. For example, the tutorial database broke this rules. We had 25 things in one line. You're supposed to put that into another table going the other direction. It didn't have a primary key. There was duplicated field names. And so what was the problem with that? What was the problem with those things? Well, I mean, code ID was just a little hard to figure out what it meant. But the problem with the TDAG 1 to TDAG 25 was that you had to look in 25 different columns to find out if something existed. And that it was really inefficient and prone to error and much easier. So if we went back to this table here, if we wanted to say, does this admission have this diagnosis? We just only have to look in one field. We'd look in diag code and say, oh, look at that. It does have this thing. And then once we find that, we can join it up to admission and say, okay, those are the admissions that have that code. Dennis, why didn't we get the assignment like that? Because we wanted to show you what crappy data looks like and that there does exist in the world. I think, yeah, I'll stop there.